All right. One of us recently did a project where we were looking at math in the real world and kind of talking about how lines can be used to show pictures. A cool application of that comes later too when we start to throw some inequalities in there. You'll see this picture has a whole region under the line, under the graph that's been shaded. This is actually used in the real world to just kind of draw some funky stuff, or in various applications. This document is like it's a PBL project, but it's a brewery. It's kind of a mock-up of a brewing situation where you've got a capacity of barrels of pale ale and barrels in the brewery that are constraints on the manufacturing process. And you've got a malt constraint and a hops constraint. These are additives to ales produced in a craft brewery. So what's been done here in the end is that we've got this system of equations. We've got these three equations on a graph, and then we're using inequalities to describe the actual kind of realistic expectations or plausible regions of the graph that would represent the system of inequalities, what's possible in this craft brewery. And you see when you stack all these equations on top of one another that you have these limits of barrels and these limits of ales, but you've got this region on the graph that shows you what's realistic, that shows you what's possible. That's kind of a crazy out there example here, but we're going to build toward that today. We're going to work toward that today. So you see here in your notes, we're just starting kind of redefining inequalities for ourselves. This isn't when we're using an equal sign. This is when we're using a not equal to sign, or when we're using a less than or a greater than sign. You've seen these before. We're also going to use less than or equal to. And we're going to use this guy, greater than or equal to. And we're not going to work towards graphs just yet. I wanted to show you that so you know where it's going to end up. We're going to start with these number lines, and we're just going to be interpreting and using these to represent these inequalities, where we have these situations where something is not equal. It's either less than, greater than or equal to, or less than or equal to. So this first number line is showing us something. It's showing us everything in this direction. So and we're going to describe what this is showing in a few ways. First, we could say this is all the numbers greater than 3. And I'd like you to write these down because this is showing a few things. It's showing all the numbers greater than 3. Whoops. Sorry, guys. Secondly, we can argue that it's showing that we could call this x, right? All the numbers we could call x. We could say that x is greater than 3. We could write it like that. We could also say that 3 is less than x. Whoops, my bad. 3 is less than x, right? Because x could be 3.1, x could be 3.2, x could be 4, x could be 5. So this x value, whatever it is on that line, is greater than 3, or 3 is less than x. Notice that was an open circle, or that boundary point was open on that graph. This guy down here is shaded in, so we've got to mark it 2/3. Here we're showing that x is greater than or equal to 2/3. Right? X could be 2/3 because we filled this in. This is possible. Or x could be anything greater than 2/3. We could also say it like this, right? We could say it the opposite way, that 2/3 is less than or equal to x. Okay, that's what these graphs are used for. So maybe pause, just see if you can draw the next one, so you can figure out what this is going to look like. Here it is in our number line. We've got a closed circle, a closed boundary point, because x is less than or equal to negative 2/3. So here's negative 2/3 in our number line. It's to the left of negative 2 before negative 3, and x is everything in the negative direction. X is less than or equal to negative 2/3. Next up, we're going to change the conditions a little bit here. Oh no, sorry, not yet. When inequality is represented by these number lines. Pause again, try. There you go, A here showing x is greater than or equal to negative 3. B here showing x is less than 2, positive 2. Alright, and now we're going to change the conditions a little bit here. We've got some different inequalities. We could talk about water usage and print storage. We could say it's from 327 to 343 liters. So if this is 327 liters, this here on a number line is 343 liters. And if the water usage, daily average daily water usage is from one to another, I'm going to argue that it could be 327, it could be 343, but it's somewhere in between there. So now we're actually putting two boundary points in this number line. We're talking about everything in between. We can of course do the same with x. This x we're saying is greater than or equal to -4, and we're saying that x is less than -2. So this graph is showing us two things. I'm going to skip E for a moment. F, we're going to say, we're going to draw like this. We'll start at sort of maybe 1. We'll throw a 2 on there. 3, 4, 5, 6, 7. X is greater than or equal to 1 3/4. So I'm going to color that in. It could be equal to that. Less than 6 1/4. So I'm going to leave that boundary point open. And then everything in between here is a possible x value. Okay, that's what that guy's going to look like. I'm going to suggest again you pause and try the last few there. Here you go. E, we're showing two things. X is greater than -3, and we're showing that x is less than 0. Two things with that little sketch right there. G, we're showing a couple things again. X is greater than -6, so it's going to look like this. And x is less than or equal to -2. So that one's going to be close, that boundary point, and x can be everything in between. There you go. The assignment's in the blog. Good luck.